Then after the Broglie hypothesis for wave nature of matter or particle. See, here one thing that we have to make clear in our mind, de Broglie suggested this thing in the form of hypothesis only, right? De Broglie suggested this thing, there is the symmetry in the nature. Always we observe a proper symmetry in the nature. So logically he thought like this, if wave have a particle nature, it implies that in certain circumstances when wave behave as a particle, then particle also behave as a wave in certain favorable circumstances, because there is the symmetry in the nature. એટલે કે જો વેવ ને પાર્ટિકલ નેચર છે તો પછી પાર્ટિકલ ને બી વેવ નેચર હોવો જોઈએ, અને એ એને કન્સિડર કરીને પછી હાઇપોથેસિસ ના ફોર્મમાં એને પાર્ટિકલ નો વેવ નેચર represent કર્યો. Means when particle behave as a wave, then if its wavelength is lambda, then we can write lambda that is equal to h by p, p that is the momentum, so that is mv. So this particular wavelength of the particle when it behave as a wave, that is called the Broglie wavelength. That is called the Broglie wavelength. And when the particle behave as a wave, that particular wave, that is called matter wave. That is called matter wave. પણ આ બધું એને હાઇપોથેસિસના ફોર્મમાં રિપ્રેઝન્ટ કર્યું હતું. એટલે એક્સપેરિમેન્ટલ એવિડન્સીસ તો જોઈએ પછી આપણે, એના વગર તો થોડું એક્સેપ્ટ થાય વસ્તુ. ઓકે, નાઉ સી here when we say lambda that is h by p, that is h upon mv. Now see, for photon we already discussed this thing, the momentum p that is h nu by c. So we can write, if we take this h by p on right hand side, then on left hand side we can write c by nu, but c by nu that is lambda. So here see, lambda that is h by p. So if we consider the photon, which one is with momentum p equal to h nu by c, then if we calculate its wavelength, then it also comes to lambda equal to h by p. Okay. Now see here, we already discussed this thing. When any electron is accelerated with the potential difference of v volt, the kinetic energy gained by it, that is given by ev. That is given by ev. But kinetic energy of the particle, as per definition, is given by half mv square. So we can write kinetic energy k, that is half mv square. Now suppose here we multiply and divide by mass m, then we can write m square v square by 2m, but m square v square, that is p square. So p square by 2m. So we can write the momentum p, that is equal to under root 2mk. Now we can replace this kinetic energy k, that is by ev. So we can write the equation of the momentum, that is under root 2mev. Now the Broglie wavelength, lambda that is h by p. So h, p is replaced by under root 2mk, or we can write h upon under root 2mev. Now see, h, 2me, all are constants. So here if we substitute the values of h, m and e, and then after if we solve it, then we will get lambda, that is 1.227 upon under root v nanometer. Now suppose here the value of v that we substitute equal to 120 volt, then this particular equation will give you the answer 0.112 nanometer. હવે આ જે આન્સર આવ્યો ને 0.112 nanometer, તો આ એપ્રોક્સિમેટલી જે એટમિક પ્લેન્સની અંદર એટમ્સની વચ્ચેનું જે સ્પેસિંગ હોય છે એના ઓર્ડરમાં આવે છે. એટલે એક આઈડિયા એ લોકોને એ આવ્યો કે with the help of diffraction experiments of electron and x-rays, કારણ કે x-rays ની wavelength પાછી આ ઓર્ડરની અંદર આવે છે, તો એનાથી આપણે આનું વેરિફિકેશન લઈ શકીએ. that is possible એમ, રાઈટ? ચાલો